Hello, this video is for Stat 310, handout number 8, part D, and it's going to include pages 26 through 31. Okay, let's go ahead and get started then. So, handout 8, part D is going to use a new example, and it is the football brain injuries data set. So, in handout 8 in our folder, you can obtain the data sets here, either the CSV version or the jump version. So you'll need to download those in order to follow along with the handout. Okay, so what is this study about? This study examined a possible relationship between playing football and then having a concussion or not, and the hippocampus volume of the brain. So we have three groups for this. We have the control group, and those are going to be individuals that never played football. So that's what's unique about Part D here, is that we will have a control level or a control treatment. So when we do our multiple comparisons, we're going to do things slightly differently. Another group that we have is a football player who did not have a concussion. We're going to denote them by FB, no concussion. And then we have football players who did have at least one concussion, and those are going to be denoted by FB, concussion. Again, the outcome or the response variable here is just the volume, hippocampus volume in the brain. The research question: do statistical differences exist in the average hippocampus volume across these three groups? If differences do exist, then investigate those. So that's giving us an indication that they want us to do multiple comparisons. Here's what the full data set looks like. But again, don't type that in. We can have that in Jump, and I'll go show you that now in Jump. So here's what the data set looks like. Let's go ahead and create maybe just a first graphic. I'm going to put group here as my X, and hippocampus volume is going to be my response. So here I'm just creating my side-by-side dot charts. One thing that we see is that the order in which Jump put these in isn't really appropriate. We have the control on the left, and then we have the football concussion level, and then they go to football no concussion. So I would anticipate football players that did not have a concussion, their hippocampus volume is probably going to be closer to the control. So let's go ahead and reorder these groups. So I have control, no concussion, and then concussion. It just makes for comparisons to be done a little bit easier. So what I need to do is add an ordering to my group variable here. And again, to do that inside of Jump, I would just select on group, column properties, and value ordering. And I would just want to put those in the right order. So again, going from control to no concussion to concussion. Apply this. So you can see that got applied to that column. And then I can go back in there and remake those side-by-side dot charts. And we're doing that by analyze fit y by x. Again, I'm using the analyze fit y by x just for my display. My analysis, I'm going to have to go underneath analyze fit model. So I can do things like add the averages on here if I want. Oftentimes I will do that just to kind of see what's going on. If you want to jitter the points a little bit, you can do that as well. So points jittered down here underneath display options. Kind of jitter the points so you can see all the points for each of those. I think it's 25 in each group. These groups are balanced. So I got 25 in each group. Okay, let's go ahead and get started with the overall test. And the overall test is just going to tell me whether or not each of these groups differ, okay, from, or at least one of these groups, do they differ from that grand average? All right, so we're going to go underneath Analyze, Fit Model. Group is going to be my model effect. Hippocampus volume is going to be up here as my response. Once we have that specified, we're going to click Run up here in the corner. Go ahead and hit Run, and I got all of our output. We're going to want to select or look at the analysis of variance output here, and we also are going to want to select our expanded estimates. So those are going to provide some additional detail. So the two bits of information that I'm going to need here is the analysis of variance and the expanded estimates. So let's go back over into our handout here and take a look at each of those. So the overall test is just, is there an effect due to group on the average hippocampus volume. That would be the alternative hypothesis. The null hypothesis is always no effect or no difference. The p-value is going to be the one down here in the lower right-hand corner given by prob F there. And that's less than 0.05. So I know that these groups have some effect on the average hippocampus volume. Again, that overall test just gives a kind of a higher up perspective. It doesn't really go into any details. It just says that at least one of these groups is having an effect on the hippocampus volume. So let's go consider the individual effects. And this is where I'm doing this underneath my expanded estimates again. So under my expanded estimates, I have 3 different levels here. So test A is going to be considering the effect due to the control group. And the control group is my first group. So that's just going to be alpha 1. So what that test is actually looking at is whether or not alpha 1 is equal to 0, which would mean there'd be no effect of the control group. Or alpha 1 not equal to 0 is going to be that there is some effect in the control group. Again, these are from the overall or average effect. So visually over here, what we are really asking is, does the group for the control differ from the overall? So that distance there, that's what that test is looking at. Is that distance between the overall and the average for group A and the average for the control group, is that statistically away from 0? And it is. That's a pretty good gap there. So if we were to go conduct this experiment again, I would expect this average to stay away from that grand average. So that p-value here is quite small, so that means it is different from the overall effect. How about B? B, once again, this is the football no concussion, is very close here to the grand average. So that p-value is not going to be small, and it's not. It's 0.3119. It's not less than 0.05. So I cannot say that the football no concussion group has a difference against the grand average of everybody. Likewise in C, C is also going to be significant. That p-value is going to be quite small here. So the people that have played football and had a concussion, we can see that they definitely have a different, I guess, hippocampus volume on average than all of them together. And in fact, it's going to be lower here. If we looked at a 95% confidence interval, it would indicate that it was under or below, which that's bad. We want a large hippocampus volume. So having concussions here reduces that down or pulls that down. How about our multiple comparisons now? So what we did there, was just the individual effects. Here I might want to compare, how did the football no concussion group do against the control? Or how did those that had a concussion and played football, how did that do against the control? So we have, as I said above, we have a control in this experiment, and that's going to be an opportunity to use Dunnett's method. So the purpose of Dunnett's method here is to be able to make comparisons against a control group. And we have a control in this experiment. So we're going to use LS means Dunnett's here instead of LS means Tukey HSD. Now what LS mean Dunnett's is going to do is just compare each of the levels against the control. It's not going to do all the combinations like Tukey's HSD does. It certainly does more than one combination, but it doesn't do all of them. So we still want to make an adjustment to the family-wise error rate, and Dunnett's does that for me. So go ahead from the red drop-down menu underneath group here, or from my treatment, I'm going to select LS means Dunnett. It's going to want to know what is your control group. And of course here I've conveniently labeled that just the control, so that's easy. I go ahead and click OK, and this is the output that I get returned. Now this is comparing again. If we look at, I have 2 tests over here. Test D is going to be comparing the no concussion group, which is the middle group, against the control. So is that vertical line there represented by D, is that going to stay away from 0? Now these aren't individual tests. This is not comparing the green line against the grand average, but it's comparing the 2 green lines against one another. Again, this one is representing, the green line here is representing the average for the control group. This one here is representing the average for the football no concussion group. I can write out what those averages look like. I just want to know whether or not those 2 averages differ from one another. Doing a little bit of algebra, we can see that really what I'm testing here is alpha 1 minus alpha 2 not equal to 0. So is there some sort of different than 0 effect when I look at that contrast or that combination there? We call that a contrast. So this p-value up here is less than 0.05, so I can say that indeed there is a difference between the control and the no concussion group. Likewise, test E is comparing the football concussion group against the control. Now that difference is actually greater than the no concussion group, so I know this one's going to be significant. If this one's significant, then this one's certainly going to be significant because the averages are further apart. And I have the same number of observations in each of those groups. So the standard error here is going to be the same if I have the same number in each of those groups. So if D is significant, again, I will know that E is significant. So those are going to be different from one another. One thing that the Dunnett's procedure does not do, though, is compare the no concussion group to the concussion group. So let's just look at the football players, no concussion against the concussion. Are those going to be different from one another? So is this difference here different than this one here? Now I can't get that out of Dunnett's because Dunnett's makes a comparison against the control. So we can actually create custom tests inside of JMP. So software packages allow us to do a custom test. They certainly can anticipate all the different tests that might be of interest. So here is a secondary research question. Do statistical differences exist in the average hippocampus volume between those who played football and had a concussion against those that played football and did not have a concussion? So again, that's the comparison that was not being done up here by Dunnett's. So I can create a custom test, or what's called a contrast, inside of JMP. To do that, from my LS means, I'm just going to select LS means contrast here. When I'm doing this test, I need to identify what the coefficients are on the effect for no concussion and what's the coefficient on the effect for concussion. So we actually have to write out what the means are for each group. I'm going to difference those. The algebra here is just alpha 2 minus alpha 3. That's what I want to test. The null hypothesis is going to be that these things are not different from one another. The alternative hypothesis is that these things are going to be different from one another. That's a typo right there. That should be not equal to. Let me go ahead and fix that. The alternative is not equal here. So what are the coefficients for this test? On alpha 2, the coefficient is actually going to be a plus 1 here. So if I take 1 times this, I'm not going to, that's the coefficient is just what would sit in front of there. That's going to be a plus 1. The coefficient in front of the alpha 3 is going to be a minus 1. So that's how I specify here. I'm going to want to put a plus 1 here on no concussion and a minus 1 on concussion group. So these coefficients right here in the middle of the screen are determined by what you want to test, and then you need to look at the coefficients on each of those parameters. Here it'd be 1 and a minus 1. Go ahead and say done. I get the output from that test over here. The output here is 0.0032 is my p-value. So I do have enough evidence to say a difference exists between these two groups. And what are these two groups again? I'm comparing those that played football no concussion against those that played football concussion. So there is going to be a statistical difference between those two groups with a p-value of 0.0032. That's the idea of a contrast. It's kind of setting up a unique or specific test of interest. There are details about whether or not a contrast is what we call pre-planned or not. If a contrast is pre-planned, I can use the standard 0.05 as my cutoff. If you're doing many contrasts, then you should, when you're making your comparisons, use an adjustment for the family-wise error rate. Here I'm only doing 1, so it's okay to use just a 0.05. I don't have to worry about controlling the overall or family-wise error rate when I'm only doing 1 test. So that notion of family-wise error rate applies to contrasts as well, just as it does up here when you're doing the multiple comparisons. Okay, let's really quickly just check the assumptions. The assumptions here for the residual plot look okay. Again, I just kind of want random scatter. I don't want outliers. I might have a little bit more scatter over here on this end, which is going to be the control group, but it's not too bad. I'm not too worried about the equal variance assumption here. It looks like it's okay. The normality assumption's got a little wave in it, but it does go ahead and stay within these bands, so I think the normality assumption is okay as well. Some final thoughts. The overall ANOVA test suggested that we had a difference between the three groups. Had a highly significant p-value here. We did Dunnett's multiple comparison procedure, and we determined that the control group was indeed different than the football no concussion group. We can look at the confidence intervals and talk about how much different. So the output for those confidence intervals are given up here underneath the Dunnett's output. You got the lower and the upper here. On page 29, I was just looking at the test, but I also have the lower and upper intervals, which tell you how different those two groups are. I learned that I have a difference between the control group and the football concussion group. That confidence interval was either even further away from zero. And then my custom test, which looked at whether or not there was a difference between those that played football, no concussion to concussion, and I found that those were statistically different from one another as well, with a 0.0032. I suppose you could compute a confidence interval, 95% confidence interval, for that comparison as well, but I didn't do that here. Okay, that does it for handout number 8, part D. Thank you much.